Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. This is the part 2 for house price prediction project. Let's continue. So, the next step we need to do is data standardization. Question is simple. Why? Features like MET INC and AVE rooms, you can again go up and see the full forms. So they are on different scales. Standardizing ensures that all features are centered around 0 with unit variance, which helps improve model performance. Again, the same thing, big numbers. So you have to change those numbers so that machine learning models can run fast. So in machine learning, it is an important step when you are working with features that are on different scales. It involves transforming the data so that all features have the same scale, typically with a mean of 0, standard deviation of 1. So if you again want to know what these terms means, I already shown you the mean. If you want to know more about these, you can again go to ChatGPT or Google and search for it and learn about it, because in Python you have to just write 1 or 2 line of code and it will be automatically done. These are just the concepts you need to know. Let's look at the real life example, then you will understand it more. So imagine you are trying to predict house prices using two features. Median income, this could range from 30,000 to 1 lakh per month. Median income. Average rooms per household, this might range from 1 to 10 rooms. So average rooms per household can be 1 to 10 rooms. In this case, median income has values in the tens of thousands, while AVE rooms only ranges from, average rooms ranges from 1 to 10. See again, so tens of thousands, big values here in median income, and but in average rooms per household, small values, and that also from the range 1 to 10 rooms. So these are small values, these are large values. Why standardization? To bring both these values on the same scale. So if you look here, the values are in same scale so that the machine learning model can run faster. So this is one board technique, standardization. So why is this a problem? Without standardization, what will machine learning algorithm do? Favor features with large numbers. So it will think if it is a large number, then it is relevant. This is what machine learning model will see. So since MET INC has larger values, so these larger values, look at these large values. So if it has larger values, the model might give it more importance just because the numbers are bigger, even if average rooms is equally or more important in predicting house prices. So it will give more importance to these big numbers and not these numbers because these numbers are big. So this is first problem without standardization. First problem. Second one, harder for the algorithm to learn. You already know that machine learning, what machine learning algorithm is. It will automatically create conditions, logics, and learn from the real world how we humans do things. So this is what machine learning algorithms will do. So in order to make the process easy for the machine learning algorithms, you have to use standardization. So without it, harder for algorithm to learn. Many machine learning algorithms like gradient boosting, logistic regression, neural networks assume that all features are on the same. So they just assume, they don't know, they just assume. If one feature has much larger value, algorithm struggles to weigh the importance of features correctly. So it will see these big numbers, these are important and these are not important. This is what it will see. But with standardization, it will see the importance of these columns. This is what standardization will do. So how it helps? Each feature get transformed to have a mean 0, standard deviation 1. This means the values of all features are, so this is what you need to look. This means the values of all features are now on similar scale. So machine learning model can understand the relevance of all these columns. So this is the formula. It is up to you if you want to go deeper into this. I have mentioned these things, how these formula work and everything, but it is up to you. I will just tell you the basics so that you will understand the process. Process is more important here. Like log transformation, standardization, you have to remember these things. If you want to go deeper into it, it is up to you. So this will be the formula. So this centers the data around 0, subtracting the mean, adjusts for the spread, dividing the standard deviation. So this is what it will do. In simple words, this means the values of all features are not now on similar scale. This is what standardization will mean. Yeah, this is important. Example of standardization. Before standardization, median income ranges from 30,000 to 1 lakh, that I told earlier. Average room might range from 1 to 10. This is also I told you earlier. But after standardization, what now will happen is, so it might now range from -2 to 2. See, earlier, now. And average rooms range from 1 to 10, earlier, now this. See the difference. So scale difference is not much now. See, and again you will ask how it is happening. So again, there is function available in Python. I will be calling the function, that's it. It will automatically do the computation, very complex computation in the background, and you just have to write 2 or 3 lines of code, that's it. So both features are now on similar scale, and the model can focus on the relationship between the features and the target variable rather than the magnitude of their numbers. So big numbers, small numbers now doesn't matter, they are on same scale. This is what standardization is all about. I have mentioned more things. So key benefits: balanced feature importance. Now the model won't favor features with larger values just because they have bigger numbers. Improves model performance. I told you earlier, algorithms that rely on distance measure like gradient boosting or KNN work much better than features are on the same scale. It helps the algorithm converge faster and gives better result. It helps the algorithm converge faster, again faster, and gives better result. This is what we want. Final model. Prevents bias in learning. The algorithm learns the true relationship between features and the target variable, not just based on the magnitude. So big numbers means bias. You know, this is the simple English word, bias, to favor something, one thing over other. This is what bias is. So against one person or group, so it will favor one thing. So this is one single English word. So prevents bias in learning. So it will not see the numbers big or small. It will understand the relevance after the standardization. Again, I told you only 1 or 2 line code. See, standard scalar, call standard scalar, and then scalar dot fit transform, and this is how you do it. That's it. Let's see. This is the code. That's it for the standardization, and this is just 1 line code for log. So they have already done all the work for you. You just have to call the functions or methods and you are done. You don't have to go into too much complexity there. these two line of code, 27 and 28. Any question? These two things that I told you, when to use log, when to use standardization. So who is asking? Okay, actually you can use only one also if you want to reduce the complexity, but it is like first you, for example, run this log transformation and see the performance of the model. So I told you in previous session, I have not included that in. Yes, I have included some basics about these errors. I will be telling you now, you know so what these errors will tell you and how to rate them accordingly. Using this you can know if your model is performing good or optimal performance for the model is working or not. So what it means is, you have created model and you are deploying it in real world. So uh, how will it perform in the real world scenario? It depends upon these things. So if you run log transformation, then you can run the complete code without standardization and look for these things, and the benchmarking of the model. If it is performing good, you don't have to apply standardization, and if applying the standardization gives you better result, then go for it. So this is how machine learning model, you should train the machine learning model according to the situation. So you can try multiple things. So these are just some few techniques. There are many techniques in the market. It completely depends upon the real world scenario. You can for example, if you have a different data set for India, because we are using California data set here, if you are running the India data set, then the results will be different. So what you will what you need to look is for the performance of the model, the model you are training. So the final benchmarking that I told in previous sessions also. So this will be the final benchmarking. You have to look for this, and if applying the standardization, and after applying the standardization, if it is giving better result, then go for it. So you have to look this way. Data splitting. So this concept I already told you in previous project, spam detection. So data splitting, what is data splitting? So I already told you that in article, that it contains, I think, 20,000 instances or so. I don't know exactly how many. I haven't seen the data set completely, but it contains large data. So what you can do is, you need two types of data to train the machine learning model. First data is for training the model, second is for testing the model. What's the difference? So the code you write on the computer manually, all the things computer is doing it automatically using a model. So to train it using large data, you can use 80% of the data for training and 20% remaining data for checking the model performance. And to do this manually is not an easy task. So how you can do it automatically? Just use this train, test, split, pass the values, and you are good to go. Only one line of code. Only one line of code to split the data into training and test set. Why? Because you can use 80% of data to train the model, and then 20% of data to test this model. So you don't have to download the different data sets for everything. Just do this and you are good to go. Where it is available? It is available in sklearn.model selection, train, test, split. This is how you do it. Only one line of code. That's it. So there is not much theory involved here. Just this thing, data splitting. We already used this technique in the previous project also, a spam detection project. and we will be using this in almost all projects. Feature selection using recursive feature elimination. What it means? Very in simple words, very easy. You can see the data set is containing many columns. Again, you can see data set is containing a lot of columns. Now can you tell me which columns are important and which are not? So I say this is important, this is important, this is important, this is not important, this is. So I am not the one to decide this thing. This is bad way. I cannot decide which columns are important and which are not. So how to do it professionally? This is one of the method. RFE, recursive feature elimination, is a method used to automatically select the most important features from a dataset for building machine learning model. It helps in reducing the number of features, making the model simpler and often more accurate. So it will automatically do it for you. So for training the machine learning model, you will get lot of data, but you don't know the importance of the data. So you can use this technique to know it automatically. This is again completely mathematical. Why do we need feature selection? When you have lot of features, data columns, not all of them might be important for predicting the target. So for final output, not all the columns will be important. Some features might be irrelevant or redundant. What redundant means is duplicate. So if I write price and price one and they have exactly same values in it, then it will be called as redundant in technology. Irrelevant, you already know what irrelevant means. You don't want those columns. Redundant means duplicate. What will happen if you do it? You already know you need hardware to train machine learning models and do AI tasks. So this is the hardware. So it is up to you how much data you can give to this hardware. It is up to you. But what will happen if it is up to you? It will slow down the model. So the output you will get from the model will be slow. Cause overfitting, where the model performs well on training data but poorly on new data. So training will go smoothly. Everything, your model, you will create your model, everything will run smoothly. But when you try to get the output from your model, then it will perform poorly. The output will be slow. So this is what called overfitting. Reduce model accuracy by introducing noise. So you already know what is noise in audio, background music or some noise. So in similar manner in model also we have noise. What noise will do is incorrect output. What noise will do is incorrect output. So to prevent this, feature selection helps you choose only the most relevant feature. This is what feature selection means. How to do it? Again, we come to practical thing. How to do it? Recursive feature elimination is one of the most popular method to select important features. Here's how it works in simple steps. So I have mentioned simple steps here. Train the model. Starts by training the model using all features. It will take all the columns and start training. This is what we humans will do. Take all the data and start training. Rank features. It ranks the features based on how important they are for the prediction. Now it will try to see which columns are important or which are not. Then what it will do is remove the least important feature. Then it will repeat the process. So again it will retrain the model again and again until the desired number of features is left. Now you will ask me one question: how to know how many important columns are important? You will ask this question. So I will show you. I have already so you already I will show you the code. briefly. So you will mention yourself how many top features you want. You will tell yourself. So will be the one of the argument that you pass to the function. You will tell the top n features that you want to this algorithm. Let's see the real world example. Not all the features may be equally important. So these 5 features, not all these features may be equally important. RFE helps to eliminate least important ones. For instance, maybe population doesn't have much effect on the house prices, so RFE might remove it. So what recursive feature elimination will do is remove the population. This is just an example. This is just an example. So what RFE will do is RFE might remove it, thinking that population is not so important in for instance, maybe population doesn't have much effect on house prices. It will think like this, and it will remove the population feature or say column. So this is what a real life example is. Now let's see how to do it. Gradient boosting regressor is the model used to rank the feature. So how to do it? Already we have a model, gradient booster regressor, available in the market. Is the model used to rank the features. So it will rank the importance of the features or columns. Then RFE is set to select the top 5 features. Then top 5 features will be selected by RFE. Check out this code, just 3 line of code. How to use it? RFE. That's it. I told you, nothing so complex. Just the theory part you need to understand. Just 1 or 2 line of code. So let's see. Excuse me. So let's see the RFE. You get it from feature selection, sklearn.feature selection, RFE. Let's see where I have used it here. And I told you, you have to specify manually like this. And features to select 5. You have to specify like this. RFE, give the model. What's the model? Gradient booster regressor, already available. RFE, give the model. Tell the features you want for training the model. That's it. Rest is simple. You must know what the code is doing. So this is what code is doing, and this will be the output. See, 1 2 3 4 5 out of these columns it is selecting 5 important columns, or say features, 5. So we have reduced the complexity for model. You understand, the data set was big. We applied the log transformation, we applied the standardization, and now this feature selection. So the data now we have is getting perfectly aligned with our real world solution. So this is the third thing that we can do. So the third thing was recursive feature elimination. So this is the main topic, feature selection, and how we did it using recursive feature elimination. How to do it? Just write this, that's it. Pass pass arguments, and this is how you do it. I will continue this project in next video. See you in next video. Have a nice day.